let's take a look at our next unit in Chemistry 30 called Organic Chemistry. Now, organic chemistry is a branch of chemistry that deals with carbon-containing compounds. Okay, so this key word here is carbon. Now, I'm going to get into this next portion, this next part here in a second, but one thing that we need to think about when we're talking about organic compounds is that it's not only carbon. We often have a molecule that's made of both carbon and hydrogen, primarily. Okay, so these are our two key components, and we call these things hydrocarbons. So generally we deal with these molecules called hydrocarbons. Now we do exclude some things that involve carbon that are inorganic or they're not organic compounds, and those things are like oxides such as carbon monoxide, carbon dioxide, and ionic compounds. So again, oxides contain carbon, but because there's no hydrogen, it makes it not organic. Okay. Also, any ionic compounds that have carbon-based polyatomic ions, such as carbonate, cyanide, thiocyanate, and carbide, things like that. So carbonate, again, if we look at our periodic table of elements, we see those polyatomic ions at the top, and carbonate is CO3 2-, cyanide is Cn-, carbide is C2 2-. We also have thiocyanate, which is SCN. Oops. There we go, SCN-. So again, these are all carbon-based polyatomic ions that aren't part of our organic branch of chemistry. They're ionic compounds, and again, they're not included in organic chemistry. Now, generally, when we talk about organic chemistry, we're looking at the chemistry of living things. Now, this can be from plants to mammals and about everything in between that involves any sort of organic compound. Now, another big source of organic compounds, especially when we look at Alberta, is any organic compound that comes from oil and gas refining. So if we take a look, we can look at different parts of oil and gas refining that we have in Alberta, and we can look at the types of products that we get from these organic compounds. Now, if we start with natural gas is generally extracted from pressure underground. Again, we use that for heating homes, sometimes fueling vehicles, things like that. Okay, we have coal bed methane. Often coal bed methane is a more complicated method of extracting methane. It's removed from a complicated system of wells that use water underground to pump this coal bed methane out. And again, we use it for the same uses as our natural gas that we see up in our first row here, but it's a little bit more complicated extraction method. Okay, we have crude oil and we have water or gas injection underground. A lot of our wells in central Alberta use water extraction for this. Okay, and often we have to use a variety of hydrocracking and reforming as well as fractionation to get any sort of product out of this crude oil. Heavy oil is involved in steam injection. Okay, and again, it has the same uses as crude oil. Again, we would have to have some sort of reforming or fractionation to get a useful product out of that. Oil sands we obviously see more in northern Alberta, and essentially it is a combination of sand and oil, and we have to do physical mining. We do steam or hot water injection in order to separate that oil from the sand, and again, we use this synthetic crude that we form from our oil sands, and again, similar uses as our other two oils up above. Coal we have from surface and underground mines, and we use this for producing energy primarily. So looking at these things, again, remember that all of these energies come from fossil fuels. Now, fossil fuels, again, essentially is all components that were natural growing elements, depending on the time period and depending on what layer we find these elements at, or these compounds at, of the Earth's surface. So we mine and dig wells and things like that to get them after several years of settling. And again, this is all organic matter that has been buried by layers of the Earth's crust, and in time it has turned into a fossil fuel. Okay, and again, remember that all energy that these fossil fuels gained came initially from the sun. So that is an important thing to remember as we go into our last unit, as well as a reminder from our enthalpy unit that all energy does come from the sun, even when we're talking about these organic compounds. Okay, if we take a look at natural gas refining, because this is such a big industry in Alberta, we do take a look at this a little bit more in depth in this organic chemistry unit, and it is good to be aware, especially because there's a lot of employment opportunities in the field of natural gas and oil, especially in Alberta for sure. So if we take a look at the components of natural gas that we would get in a sample of sweet natural gas from a gas field that we have in Alberta, we would definitely get some nitrogen components, some carbon dioxide components. Now what you'll see is methane is a key component that we see here. It has a great percentage of what you would get out of a sample of natural gas, and we see it to be about 83% methane. Okay, again, ethane is another component that is a fairly large component. Then we have propane, butane, pentanes, and hexanes as well present. So notice again that our methane is our key component. Now, methane is used often, obviously, in heating our homes and all kinds of industry that we have. So it is an important component of natural gas. Now, we see also here that our boiling points, generally our boiling points as we go from methane to ethane to propane to butane, we'll see that the boiling points gradually increase, meaning that this will be found as a gas at room temperature, while as we move down here, we might see that at cooler temperatures, we actually see butane more as a liquid. Obviously, butane we use in lighters, and it is a liquid when it's compressed. So that is a good indication also that it has a higher boiling point. So some uses of these natural gas components. Notice we've kind of pulled these 4 out of that list that we had on our previous slide there. Again, methane is used for heating homes, fueling taxis, producing hydrogen and methanol. We have ethane that's cracked into ethene, and we produce a lot of petrochemicals from ethene, like polyethylene, so plastics, things like that. That's very important. If you are familiar with the Joffrey plant, that's the primary thing that they do there. Heating homes and vacation trailers is propane. Often barbecues, things like that are also use propane, to be the primary heat source there. And we have pentane, which is a winter additive to gasoline, and you have greater vaporization, kind of prevents gasoline from freezing up as well. So sour gas. Sour gas is that really stinky gas that you smell on occasion, especially if you're in close to a sour gas oil field. Sour gas is really quite a harmful substance, especially in high concentrations. And essentially, sour gas is this H2S, or hydrogen sulfide. Now, people that work in the oil field have to get very specialized training and often have to use, if they're working in a sour field, they have to have proper personal protective equipment in order to work in that field and proper training to work in that field. So we often call this H2S as sort of our old stinky egg gas, and you probably will be familiar with this, especially if you're from Alberta, understanding what sour gas smells like. Now, obviously, because sour gas is very harmful, we have to use a different method of refining and production when we are in a sour field. So we often use a chemical amine that will basically purify a first section or first phase of our H2S in order to be more usable of a substance. So we use diethylamine, okay, which is this compound here. And we also need probably quite a bit of pressure and temperature to remove the H2S. Now what happens is some of this H2S is removed from the gas component, and from there it mixes a little bit with oxygen to form sulfur dioxide. Now from there we have our H2S and our new sulfur dioxide that's been formed, and we react it in a Claus converter to obtain some elemental sulfur. Now there's a few places in Alberta, one of them being Sundre, that does use this process in a Claus converter to pull out elemental S8 or sulfur from a gas sample in order to use that for other industrial processes. Now, this kind of wraps up our little introduction into our organic chemistry. Obviously, in organic chemistry, we can look at living things, we can look at biological systems, we can look at organic systems in terms of industry, and especially in Alberta, we have a huge industry that is reliant on organic compounds, being the oil and gas field. So, if you need to go back, jot down any notes, do so now. Good luck.